Okay, so now let's look at the general multiplication rule for probabilities and also tree diagrams. So here's an example. About 55% of high school students participate in a school athletic team. Roughly 6 of these athletes go on to play on a college team in the NCAA. What percent of high school students play a sport in high school and go on to play in the NCAA team? Well, 6% of 55%. Multiplication is roughly 3.3%. You're simply just doing the multiplication of those two percents. So, the general multiplication rule, probability of A and B, so the probability that they play in high school and go on to play in NCAA, is the probability of A intersection of B, A and B. That is equal to the probability of A times the probability of B given A. Remember, B was the event of them going on to play in NCAA. A is the event that they play high school. So, the Pew Internet and American Life Project reported that 79% of teenagers aged 13 to 17 use social media, and 39% of teens who use social media feel pressure to post content that will be popular and get lots of comments or likes. Find the probability that a randomly selected teen uses social media and feels pressure to post content that will be popular and get lots of comments or likes. So the probability will use social media. So using social media is 79%, so 0.79. And then the probability that they will post content, which is 39%, 0.39. So 0.79 times 0.39 is 0.308. Alright, so a tree diagram. Usually when you have a sequence of events, event 1 happens and then another event and another event, use a tree diagram to keep track of what has happened with each trial. Think of flipping a coin. Heads, heads, tails, heads, tails. Being able to keep track of that. But then a tree diagram is going to allow you to also keep track of the probability of each flip. So, tree diagram shows the sample space of a chance process involving multiple stages, or trials. The probability of each outcome is shown in the corresponding branch of the tree. All probabilities after the first stage are conditional probabilities, because the second flip could have been determined based on the first flip. A coin might not be the best example because it's 50-50 each time, but you can still do a tree diagram with it. So here we have a tree diagram displaying the sample space of randomly choosing a school day and noting if Shannon hits the snooze button or not, and whether she gets to her first class on time. So there, in your textbook, there is a little scenario typed out that talks about a student, if she hits the snooze button or not, that she actually make it to class on time. So here our tree diagram says that there's a 60% chance that she hits the snooze button. So that means there's a 40% chance that she doesn't. So if she does hit the snooze button, there's a 70% chance that she's on time and a 30% chance that she's late. This is the conditional probabilities here. Probability that she's on time given she hits the snooze button. Probability that she's late given she hits the snooze button. And then similarly here at the bottom, being on time but didn't hit the snooze button, and being late and didn't hit the snooze button. So recently, Harris Interactive reported that 20% of millennials, 25% of Gen Xers, and 21% of baby boomers, and 17% of matures, age 60 and older, read more ebooks than print books. According to the U.S. Census Bureau, 34% of these 18 or over are millennials, 22% are Gen Xers, 30% are baby boomers, and 14% are matures. Suppose we select one U.S. adult at random and record which generation the person is from and whether she or he reads more books, ebooks, or print books. So first we're going to draw a tree diagram. So randomly choosing a person. So millennials were 34%, Gen Xers 22%, baby boomers were 30%, and matures were 14%. This is the breakdown of the population. Then, your next branch will be the probability of them reading ebooks or print books. So 20% of millennials read more ebooks, so that leaves 80% of them reading more print books. 25% of Gen Xers reading ebooks, 75% print. 21% of baby boomers read ebooks, 79% read print. And then 17% of the mature group read ebooks, and 83% read the print books. So now we want to find the probability that a person reads more ebooks than print books. So, since we're worried about reading more ebooks, we're only worried about the branches that end with reading more ebooks. So, we have 34% that are millennial reading ebooks, 20%. So, here we have it matched up from the branch. 34% of 20%, 22% of 25%, 30%, 21%, 14%, 17%. So we would find each of those products, the 20% of the 34%, the 25% of the 22%, the 21% of the 30%, and the 17% of the 14%. Find all of those products and add them together, because all four of those scenarios are about people reading more ebooks than print books. So our final probability is 0.2098. So approximately 21% read more ebooks than print books. Now, suppose that the chosen person reads more ebooks than print books. What's the probability that she or he is a millennial? So here we have a conditional probability. We're given the parameter that they read more ebooks. So we're only worried about the branch with ebooks. But then we're looking at whether he or she is a millennial. So we're looking for a millennial and reads more ebooks divided by probability of reading more ebooks. So millennial and reads more ebooks, 34 and 20. So 20% of 34, that's what gives us the 0.068. And then reading more ebooks was the amount we found before, the 0.2098. So the final probability of randomly choosing a person being a millennial, given that they read more ebooks, is 0.3241.